it's Kelly. So, as you all know, I'm really into Hoyas, right? And I like the Hoyas with a lot of venation. And I was recently looking at some of my Hoyas with their venation. I'll show you one right here, Hoya Melodithii. And I was wondering about the venation, because the venations don't look exactly the same, right? Which they're not going to. They're different leaves, different veins. But I was looking at some of my other Hoyas. Here's just the Hoya Macrophylla albo marginera. And you know, I play around with the lighting situation that I have and stuff like that. And sometimes the leaves just come out really weird, like not even recognizable to the other leaves. This is my Hoya cardophylla. Now this large leaf right there is an original leaf. Then the next leaf it gave me was that leaf, which doesn't look anything like it. Then I got that leaf, and I'm not sure, this is the newest leaf. I'm not sure which leaf came next out of those two. But as you can see, every single leaf is different. Like some have like an iridescence where they're like shiny. Some are venated, like they have a lot of veins, venated, right? Venate. I don't know if that's a real word, but we're gonna go with it. And also the colors of the leaves change too. And now I'm always moving my plants around. I'm always changing the lighting. I try to stay regular with the watering, but I mean, sometimes you gotta go somewhere and, you know, you're gone for a couple weeks. It just happens. So I decided I wanted to learn more about venation and what can make a venation change in the same plant. So I deep dove into Google. I'm going to share with you some of the stuff that I learned about venation. I'm going to also throw up pictures that I find so that you can kind of see what I'm talking about, because for me, I'm a very visual learner. I need like pictures, descriptions, drawings. I need to, you know, write it all out for me to understand it and process it. So I will provide pictures so you can see what it is I am trying to convey to you. So first we're going to talk about the structure. So the venation veins are vascular bundle sheaths composed of xylem and phloem cells. So xylem cells transport water from the petiole or the stem to the lamina mesophyll or the leaf. And phloem cells transport sugars, glucose, that are made in the chlorophyll of the chloroplast through the process of photosynthesis from the leaf of the plant, from the leaf to the rest of the plant. Also, okay, I think my neighbors are inside now in their apartment. Hopefully you... Okay. Alright, you shouldn't hear any more of that, I don't think. We'll find out. Alright, so, what was I saying? Okay, so any green part on a plant can photosynthesize, right? That's where the chlorophyll and the chloroplast is, and it takes in the light and photosynthesizes, makes the sugar. So, that's that. Alright, there's also the function of veins provide a skeletal support to the leaf so that it stays stretched, reducing wilting, so that the leaf can get as much sunlight possible and photosynthesize as well as transpire as much as it needs to in order to survive and thrive and later on reproduce. Right? Okay, so that's like the basic structure of veins and why they're important and why the leaves have them. Alright, so I also learned, before I go on, all of the papers that I found, I'm going to link in the description below so that you can look into it, and maybe there's something I missed or something you want to look deeper into, you can do that. And you can also like find your own articles and stuff. Like, it's not, you know, this is just what I found and what I learned, so. Okay. Alright, so there's this thing called a vein hierarchy. So leaves with more veins or higher branching orders have smaller diameters with greater branching frequencies and lengths. So basically that means if you have more veins, the diameters of those veins are going to be smaller, which will make it a little harder to see in the leaf. And you're going to have more of those veins, and those veins are going to be, or tend to be, longer, like throughout the leaf. And those you'll see more in like the minor veins. Now we're going to talk about the orders of the veins. So there are 3 orders of veins. The first order is concerned about the main veins, whether they have a palmate pattern or a pinnate pattern. The second order talks about the secondary veins, right? They're a little bit smaller than the main veins, but they're not minor veins where like they're really hard to see. So the second order veins are broken up into 3 types. They have I'm going to butcher how to say this, craspedodromous type veins, which run all the way to the leaf margins. Okay, they also have the second category are bronchidromatous vein systems, which those veins loop and connect with each other. And then there's eugocamptopodrominous vein systems. Those vein patterns are intermediate, with some veins looping while others reach the end or the margin of the leaf. So that's that. So the third order, those consist of the minor veins, and those are broken up also into 3 categories. So there's percurrent veins, which are throughout the leaves. There's ramified veins, which branch out, which have a branching out type of pattern. And then there's cascade or reticulate veins, which they connect in a network type of pattern. So also in my research, I found this thing they called vein length per area, or basically the vein density per leaf per plant. So VLA. And I learned a couple of just fun facts about that also. So deciduous plants have a larger VLA than evergreen plants, which makes more sense. The leaves are larger against, evergreens where you have like pine needles, right? If there's not as much leaf, you can't have, you're limited on the amount of veins you can produce and make. Herbs have less vein density than shrubs, and shrubs have less than trees. That basically follows the stomata density of the leaves. So the larger the plant, the more leaves there are, the more veins you can have. Basically, right? Pretty simple, I think. Okay, so also the VLA can change, as you could see like in the cardophila. It can change, the same plant, it can change based on its environment and things like that. So I wasn't like taking notes on what I was doing. Maybe I should have been. But, as I moved it, you can definitely see in this plant at least, like each leaf changed how it grew. So just interesting, and maybe I'll start getting a little more scientific with it and putting it in light, and maybe get a light meter so I can read the light and write it all down, and then maybe I can share with you, what progress I have in my plants. So we'll see. Okay, so based on that, there's a couple of just little fun facts on how you can increase your vein length per area or your vein density in a plant. So you have an increased VLA with sun-adapted plants. So if you take the same plant and you adapt it slowly into a more sunnier area, you're going to get more veins. If you take that same plant and then slowly adapt it to a more shaded area, you're going to get less veins in the newer leaves, right? You're going to have an increased VLA in arid areas. The reason for that for the plant is because with pulses of water, in arid areas, you're dry most of the year and then you get some really heavy rain. In those environments, the heavy pulses of water allow more photosynthesis to occur in those plants, so those plants need to have more veins in order to get the water to where it needs so that it can photosynthesize and get as much, bang for its buck for the amount of water, because the water is the limiting factor for those plants in those areas. And opposely to that, the VLA decreases in areas of high precipitation. And that's because the plants are readily getting water. They don't need as much surface area with their veins to, you know, do photosynthesis. They get what they need more often than the arid plants do, basically. And also, aquatic and succulent plants tend to have a lower VLA as opposed to regular, I guess, just regular house plants. And that's also because I think succulent leaves hold on to so much of that water, again with the pulsing, and then also aquatic plants, you're in water, you have what you need for that. So that was what I kind of learned on my little deep dive about venation and stuff like that. And now I'm going to go through the types of venation. So if you Google types of veins, you're going to get this image, right? And it shows you 9 types of veins. And I think it's just cool to know the types of veins, what they look like and stuff like that. So then, you know, if you're taking notes on your plants, you can write the type of venation you think your plant has. And you can also see how the veins change in the plant based on what environment changes you do and what you know, just what you see, right? I just think that's cool. I don't know. I guess I'm a nerd. Whatever. It's cool. Alright, so the first one is parallel venation. These are in monocots. These veins are arranged axially and not intersecting. The second one is longitudinal. These veins align mostly along the axis of the leaf. Palmae have several primary veins diverging from one point, right? And then dichotomous veins have a branching symmetrically in pairs. Reticulate veins are smaller veins forming a network, so those are like the secondary veins. Cross-venulate are small veins connecting secondary veins, so those are the minor veins. Rotate venation in petal leaves, the veins radiate from the petiole, right? So you'll have kind of like the Pelia peperomoides, where the petiole is more in the middle of the leaf, it's not at the end. And yeah, so that is the more rotate type of venation. Arcuate veins are secondary veins that bend towards the apex, and pinnate veins are secondary veins that are paired oppositely. So hopefully you learned something here. Drop it in the comments below. If I missed anything, like always, let me know in the comments. If you have any articles that deep dive into venation and give some more background on maybe the evolution, that was kind of what I was going for. I wanted to know how you went from a parallel monocot type of leaf in venation to, you know, the different types of venations that there are today, to try to figure out how, you know, the plants evolved and what that said about their environment, so that I can provide a similar type of environment for the plants that I have based on the venation. I didn't really find anything that specific. Again, you know, I am only one person. I can only read and look at so much information. So if you have any of that information, please let me know. Drop the links in the comments below. Hit me up on Instagram at Kelly_Hoya. And yeah, so that's what I learned about venation, guys. Okay, so until next time, relax, plant, and peace out.